Very good morning to you, sir. This is for subject EET 208 Electrical Power Technology. Hello, my name is Beckham Umpie, Anak Brandon. My metric number is 1810912110. I'm from RK23, Group 1. Without further ado, we will proceed to our talk. So this talk is going to be about the project that I've done for the past few weeks, stimulation and problem solving. The title for my project is three-phase system with 2-watt meter method. Let's proceed. What is three-phase system? Let us briefly go into my introduction for this project. Three-phase system is a system which consists of three phases. They will go through three wires and a neutral wire that will pass by the fault current which will flow to earth. The overall sum of line current must equal to 0. An angle of 120 degrees separating each phase. This angle must be the same for every single phase, for there is three phase which equivalent to 360 degrees. The current in neutral wire is equivalent to the total sum of the line current from the three wire. This is the brief introduction for three-phase system. Let's proceed. What are the objectives for my project? First, I want to find out the relationship between the given voltage drop in BS7671 and the experimental voltage drop. Here we would like to look into the value of voltage drop that is given from BS7671, and we would like to compare with our experimental voltage drop, which will be our metric number that will be used as our voltage, as our load. Secondly, we want to compare the active power by using 2-watt meter method and also the calculation. Here we will look into the differences, the experimental value and the calculated value of our watt meter method in this experiment. Thirdly, we would like to study the three-phase system of a star connection. This is the three objectives that will be done in this experiment. Next is we will look into the methodology that we will be using in this experiment. First and foremost, we will study on three-phase system regarding 2-watt meter method. Next, we will do a research on BS7671. After that, we will construct this circuit by using PSIM software. This software we will need to download in the internet, and by using this software we can construct the circuit and we can stimulate the circuit. Next, we will observe and record the obtained data. All this data will be recorded by using tables, and we will compare the value of the data that we have and the value that is given from the stimulation that we have done. Next, we will calculate the actual value and also record the actual value that we can obtain. Next, we will compare the experimental value and calculated value. Last but not least, we will make a discussion and we will conclude it with a conclusion. Next, we draw a circuit by using PSIM software. There are two circuits that is drawn in this software in order to measure the line current, the phase voltage and the line voltage. And also, let's not exclude the active power as well. So this is the circuit that is drawn by using PSIM software. This circuit is to measure the line current, the phase voltage and the line voltage. As you can see in this circuit, there are 3 voltmeter connected to the load, and there are 3 ammeter, which is also connected to the load. This we will calculate and measure the line current, the phase voltage, and the line voltage of this circuit. Whereas for active power, we will use another circuit. We will exclude the voltmeter, as you can see from the first circuit. We will exclude the voltmeter and we will use 2-watt meter. Here we can calculate the active power of this circuit. Now I would like to talk about the result and the discussion that I have obtained in this experiment. There are 4 tables in total: line current table, phase voltage, line voltage, and also active power. Let's proceed to the first one. This is the experimental line current and the calculated line current that I have obtained in this experiment. As you can see, there are a slight difference for both experimental and calculated value. For our line current, the experimental and calculated value are about the same. And for line current A, percentage difference is 0%. They are equal to each other. For line current B, the percentage difference is 0.71%. For line current C, percentage difference is 0.83%. Percentage difference for all 3 lines is very small. Next is our phase voltage. This is the experimental value and the calculated value for our phase voltage. It's also the same. They are slightly different from each other, but they are about the same. Phase load A, we have a percentage difference of 0.02%. Phase load B, we have a percentage difference of 0.44%, whereas for phase load C, we have a percentage difference of 0.48%. All of the percentage difference is less than 1%. This shows that the experimental value is acceptable due to small differ with the calculated value. Next is our line voltage. As you can see, it's also the same. Line voltage EAB, line voltage EBC, and also line voltage ECA. The value of the calculated line voltage and experimental are about the same. For the first one, EAB, the percentage difference is 0.12%. Second, percentage difference is 0.62%. And third, percentage difference is 0.15%. All of the percentage difference of 3 line voltages are less than 1%. For our active power, the experimental value in unit million watt. For experimental value active power, it's 682.90 million watt. Whereas for our calculated active power, we obtain is 702.28 million watt. This is a very high figure, therefore we will use million watt. For our conclusion, after all the simulation and calculation and the experimental value that we obtained in this experiment, I would like to conclude that the percentage difference for line current, phase voltage, and line voltage is very small. All the percentage difference is less than 1%. Throughout this experiment, I have obtained that the voltage drop is 12.74%. This voltage drop exceeds the requirement value of BS7671, where the requirement value is 3%. As you can see that the difference between these two voltage drop is a big value, so this voltage drop is not acceptable because it exceeds the requirement value of BS7671. As a comparison value for the active power, there is a percentage difference of 2.84%. This is still very small for percentage difference. Hence, for our overall objective, I would like to say that our overall objective is achieved. I think that's all for my part, sir, and thank you, and sorry if there is anything that is lacking in this video. I would like to say thank you, sir, and before I end my talk, Stay home, stay safe, stay clean, sir. Thank you, sir.